So what do we remember about roots?
The little number right there is how much it needs to be by.
Okay, so the A is our index,
Index.
right? So this tells us how many groups we need, right? We've kind of talked about it as like a currency exchange. So it's telling us how many we need to have in the groups that we need to pull out. And then we have our variable underneath, and we have just a regular exponent, right? Here, so let's look at something. When we look at the square root of x squared, have you noticed that when the index and the exponent match, it just all disappears? And all you have is your radicand that's underneath, right? Because it's telling me I need to, the index is telling me this is what I need. This is telling me what I have. I need to, I have to, so all I have is my radicand, okay? So let's look at square root of x to the 6. I need groups of 2. I have 6. 3. So same as if we go back to elementary, right? I need groups of 2. I have 6. I have 6 apples. I need groups of 2. What are we doing? Dividing. We're dividing our exponent by our index. Okay? So you can also divide your exponent by your index to figure out what you have. And then the leftovers, remember when we talked about whenever you had, say you have 7 and you're in elementary math. So I have 7 apples, I need them in groups of 2. I have 3 sets and I have a remainder, right? So the remainder is going to remain underneath. Okay, so these are shortcut ways of thinking as we get into the just faster ways to work through our roots. Okay, so let's use that same concept and work through a couple of different ones. We need to know this because we're going to move on to rationalizing and adding stuff to it, okay? So I have the square root of x to the 15th. So instead of dividing this all out and circling them, right, I can say 15 divided by 2 is 7. So I have how many groups?
7.
I have 7 groups. So I'm going to pull out 7 groups. What do I have remaining underneath?
X. Just X.
To the 1, yeah, if that helps to see. So I did 15 divided by 2 gives me 7. This says 1/2, so we'll also use this in a minute. So I have 7 and 1/2. So I have 1 with my root of 2, right? If I was to group this out, we did 15 of them, I would be able to get 7 groups. Seven groups of x, so each of those comes out. So I have 7 x's, remember? So then basically we are using our same exponent rule, right? And I'm going to add up all of these ones. So I have x to the 7th, and then I had 1 left over. So I have x to the 7th with 1 left over underneath. Okay, let's work another one. Square root of x to the 7th, y to the 12th. So I need groups of 2. How many groups of 2 can I get out of x to the 7th?
3.
I can get 3 groups of 2. So that's x cubed. right? I pulled out 3 groups. How many groups of 2 can I get out of y? 6. Y to the 6. And did I remain anything underneath?
X.
X. Because 3 times 2 is 6, and I needed 7, so I need an extra 1 left underneath. Okay? Do we need to break that out? Is that making sense?
Yeah.
Okay, let's do another one. Okay, cube roots. I need groups of 3. How many groups of 3 can I get out of x to the 9th?
3.
3. So I've done 9 divided by 3. I have 3 groups of x. How many groups can I get for the y?
4.
4. So that's simply x to the 9th, y to the 12th, y to the 4th, okay? So see, we're able to use our division just for shortcuts instead of, you know, multiplying them out and finding them. That helps whenever we get into these bigger radical numbers. Okay, let's do this one. Okay. What is my index? 3.
Yeah.
Our index is 3. So we need groups of 3. How many groups of 3 can I get for the x's?
3.
So I have 3 x's came out, 3 groups came out, and what? How many are left under?
2.
2. Why 2?
Because that's what you have
9.
left over.
Because 3 times 3 is
9.
9, but I started with 11, so 11 minus 9 is 2, okay? How many groups of 3 can I get out of the y's? 1 group. How many y's do I have any remaining?
1.
I have 1. 1 times 3 is 3, but I needed 4. Okay, how many groups of z can I get out?
3.
3. Do I have any left?
2. 1. We'll go at 1. You're right.
This 3 goes here, and that's there. And I have 1 z left, right? 3 times 3 is 9, plus 1 is 10. So this is how we can go backwards. So if I start and I wanted, you got those down? For my faithful board copiers. Okay, so let's do this one. Okay. How would we put these all back underneath?
Times it
by 3.
and then whatever you have left over you add.
So we would take our exponent, and here's our index, and we would multiply them, right?
Yes.
So underneath, I would have an x. If I put this x back underneath, it would have been x to the 6th, right? Because I needed groups, so it says I had 2 groups of 3, so it'd be x to the 6th. How many y's would I have underneath?
2 times 6.
So 6. How many z's would I have underneath? 3. Excellent.
Yeah.
These, what do I do now?
Add.
We add, so we had x7, y to the 6th, z cubed. The cube root, okay? So that's working forward and backwards. Got it?
Do we ever need to go backwards?
No, I don't want you to go backwards if we're simplifying. I'm just showing how they work in and out because we're about to, have to get them out of the denominator. So we're just understanding what it means. So we have remembered that it's really PEMDAS, right? So our exponents and our radicals, I was thinking like a seesaw. So, or I even almost brought just even a ruler. If you think you've got exponents on one side, roots on the other, they undo each other. Okay, so we can flip back and forth between them. Understanding that the index is telling me how many we need, the exponent is telling me how many we have. Okay, so for this week, as we're going to work through radicals in the denominator of a fraction, And we're also gonna work through changing this. So since we were just working, I'm gonna do, this is gonna be, if you care about your stuff, lesson 37. Okay. So as we were just talking about, that was a shortcut way of rewriting how to figure out what to do by taking our exponent and dividing it by our index, correct? Nathan mentioned whenever I did x to the 7th, we had square root, he said, or maybe it was 15, right? And he said it was 7.5, right? So we ended up with 7, and we had a square root of x left over. Okay.
Oh.
Do you see a half in there? So we had x to the 7th times, so x to the 15th, square root of x to the 15th, simplified down to, we did 15 divided by 2, so we said we had 7 groups, and we had 1 left over on the inside.
You do the 1 divided by 2.
Nathan said, oh, I've got 15 divided by 2. That's how we were figuring that out in the first place, right? He said, oh, it's 7.5. Do you see 7.5 anywhere in that?
Yep.
Okay, where do you see 7.5? I have 7 whole on the outside, right? Remember, exponent divided by the index, exponent of 1 divided by my index of 2. Another way to write the square root of x, if it's x to the 1, is 1/2. X to the 1/2. Okay, so this is a different way of rewriting it. So how do you think we would write the cube root of x?
X to the 3rd.
X to the 1/3. Does that make sense, Nazarene? Okay. So when we're thinking, hey, my shortcut way, this is how many I have, this is how many I need. So I take my exponent divided by my index, my have divided by my need, right? Group, so back to that basic division. We can rewrite x to the 15th as x to the 15th over 2, right? So I could just start with my big one all the way out. Right? So square root of x to the 15th could be written as x to the 15th. Yes?
So can you solve that if the x, like, pretend like x was like 4 and the exponent was 1/2?
So what?
What would that equal 8 or what?
Well, we're not going to have this would be the same as, you'd have to write the square root of x on the inside of the square root, which is the 4th root. Right? Because this is really 1/2 divided by 2, but we can't divide by that. We can't divide with fractions, so we multiply times the reciprocal, so we still end up with 1/4. And this is x to the 1/4. Ooh, that was a really awful 4. Does that make sense?
Yeah.
Okay. So, if we have square root of x to the 7th, how would I rewrite that as a fraction?
X6.
And it just
X to
initially,
the 3rd.
7/2,
Oh, that, yeah.
Oh, okay.
right?
I was trying to.
No, and so now we want to simplify.
Okay.
Right? So how many times does 2 go into 7? 3.
3
And what do I have left over?
1/2.
X to the 1/2, which x to the 1/2 we rewrite as a square root of x. Okay? Same things, we're just like putting on masks. So I'm just switching in and out, okay? So if I have the cube root of x squared,
2/3.
2/3. Can I simplify that anymore?
No.
No. Now, what we were learning this last week, we were learning that if we have the square root of 2 plus 2 square root of 2, when we are adding roots, what do we need? Our entire radical has to be exactly the same,
Oh yeah.
correct?
So it'd be 3 to square root.
So can I add these two?
Yeah.
Yeah. So I'd have 3 square roots of 2, right? Now, and if we are multiplying roots, the indexes have to be the same, right? Whoop. There we go. So I'm not an English teacher. Okay, the indexes have to be the same because you have to be putting them in the same amount of groups, correct?
Yeah.
So this would just be 2 square roots of 6, correct? So we multiply what's underneath the radical, our index stays the same. So that works out real easy when we're multiplying and our index is the same, or when we're adding and our roots are the same, correct? Easy breezy. So now, how do you add the cube root? So before, we had said I've got a cube root of 2 plus a square root of 2, right? Can we add those?
Mm-mm.
No. When it's in this form, can we add them?
No.
No. Okay. So let's take what we just learned. How can we rewrite this?
2/3.
No. 1/3. 2 to the 1/3. Right?
Oh.
So 2 really has that. And what does this really have?
1/2.
2 to the 1/2.
You want to make it in proper fraction?
Okay.
That's it.
So now if we add them, what is our rule for adding with fractions?
Same denominator.
The bases have to be the same, right? Let me do this with multiplication, it's easier to start here. So in the same vein, when we were talking about to multiply roots, the index has to be exactly the same. But the index here says I need groups of 3, the index here says I need groups of 2. We can't multiply those together. But now we've changed them to fractions. The rule for fractions is our bases have to be the same, correct? Remember our exponents that we were just learning last chapter? So now my base is the same, so what do?
Add.
I add 1/3 plus.
6. No, 5, 6.
So how do I add those two?
1/5?
Nope.
Wait.
5,
To add fractions, what do we need to do to add fraction? They need to have the same denominator. This is the part that gets tricky. This is the one. So the least common denominator is 6. So 1/3 is the same as 2/6. 1/2 is the same as 3/6. Now they have the same denominator, so I have 5/6. So I have 2 to the 5/6, which can be rewritten as the 6th root of 2 to the 5th. Same thing. Remember, what I have divided by what I need, exponent over index. So now we can can multiply roots that we couldn't multiply before because our rule said the indexes have to be the same. Well, I can't multiply it when it looks like this, but I can multiply it when it looks like a fraction. I'm getting it, okay, we're gonna do some more, okay? Does that, see how we're gonna be working through, we're gonna do a lot of practice on these. We're gonna be working through trading back and forth.
Sorry, my face looked.
I like confused faces, and we can unconfuse them. Okay, so thinking about, so they use this term, rationalizing a denominator, okay? When we've only been working with roots just straight across, okay? So we learned that if we have square root of 3 over the square root of 2, we can rewrite that as what?
The square root of 3 over 2.
3 over 2, right? We can combine it all and have it on the inside, right? We know that. And then we can simplify this if possible, right? So if I had square root of 20 over the square root of 5, I would do 20 over 5. 20 divided by 5 is square root of 4. Square root of 4 is 2. We got a nice happy answer there. Okay. So what do we do when we don't get a nice happy answer?
Like, what do you mean not a nice X? Like a decimal or like
Decimals are fine.
or
We
a
prefer.
fraction?
So what if you end up with, so I have square root of 16 over the square root of 3.
16 going to 4, if you want to do it that way.
Yep, so I have 4 over the square root of 3. Correct?
Yeah.
That is not simplified. In the rule of mathematics, a root in the denominator is not simplified. We cannot leave that there.
Good to know, good to know.
Okay? So at this point, you're like, I got an answer, I simplified it. This is not fully simplified. So having this in the denominator is a no-no. We need to get rid of it. What is our rule with math? We can change anything by multiplying it by the number 1, correct? Because does it change it? No, it's just a different format, right? I can take one pizza and I can cut it in half. Or I can cut it in 4ths, or I can cut it in 8ths, or I can cut it in 16ths. I still have the same, single pizza, but I haven't changed it. I just cut it in different pieces. I gotta turn that alarm off. Okay. So when we don't want a root in the bottom, we have to change our fraction. So we're gonna multiply it by the number 1, which just means the same thing on the top, same thing on the bottom, right? My square root of 3 tells me what? I need how many?
2.
I need 2 3s underneath the radical, right? How many do I have? So how many do I need to, I need another one, right? So what is our rule, our radical rule? When our index is the same, right? We just multiply what's underneath. So then that's the square root of 9, which equals 3. Okay, so when my index is the same, I can just multiply the bottom. So I'm gonna make sure I have the same index. It's gonna be a square root. So now it says my indexes are the same, so I can multiply anything I want to underneath the bottom. How many 3s do I need?
1, 2,
I need 2. How many do I have?
1,
So how many more do I need?
More.
1.
1. I need 1 more. So whatever I put on the bottom, I'm gonna put on the top. I feel like I'm writing in 3D. So my rule, our rules are, now I have a square root index. What do I have underneath?
9.
3 times 3, which is also 9. And I have 4 square root of 3 on the top. Okay. So on the bottom, let's rewrite this. 3 squared. I need 2. I have 2. So what do I really have?
9.
3.
9 squared.
I really just have 3. Right? What? Yep. I need 2. I have 2. So all I have is the radicand that was underneath, the 3. And on top I have 4 square root of 3. This is simplified.
So it can be on the top and on the bottom.
It can be on the top, but it cannot be on the bottom. Okay, let's work through another one. Square root of 5 over the square root of 12. Does it do me any good to put these under one radical? Does it do me any good to go backwards and say square root of 5 over 12? No, I can't simplify it, correct? So that doesn't do me any good. So we're gonna move forward. The problem is, I have a radical in the bottom. Okay? There's 2 options here. I can try to simplify out my radical. What is the square root of 12?
The 4 can go 2 and 2.
Yeah, so 2 square roots of 3.
Yeah.
Okay. So we can do it that way. And I can rewrite it. Two square roots of 3. Okay, we're going to solve it both directions across. Okay, so here my problem is my square root of 12. It says I have how many? I have 1. I need
2.
2. So what do I need to multiply by?
Itself.
By itself. Excellent, Nathan. Square root of 12. If I multiply it by the bottom, I have to multiply it times the top. So what do we end up with on the bottom?
144.
Just 12, no.
Oh.
Remember, a square root of 12 times a square root of 12 gives us the square root of 12 squared, right? 12 times 12, or square root of 144. So then I have to work backwards. So it doesn't do me any good to go ahead and multiply it out. Remember, we want to use our shortcut method where our A and our N equal, and that way they can cancel out. Okay, so now I have the square root of 12 squared, which gives me
Just 12.
just 12, right? Because those cancel. And on the top, we have square
60.
root of 60.
Do you want to simplify that?
So then can we simplify that?
Yeah.
Square root of 60 is 4 times 15.
4 can go out.
The 4 is really what, 2 squared,
Yeah.
right? So I'm going to move a 2 out. So now I have 2 square roots of 15 over 12. Now everything on the outside are our whole numbers, so we can reduce that. 2 goes into 12 how many times?
6.
6. So I have the square root of 15 over 6 would be my answer. Okay. If we went ahead and simplified the 12 in the first place, where's my problem?
3.
My problem is the square root of 3. Okay, same problem, Nazarene. We're working at 2 different ways. Okay, we started with the square root of 5 over the square root of 12. So the top one we work through leaving the 12 and multiplying it out. The bottom one we have simplified the square root of 12 to 2 square roots of 3 because 12 is 4 times 3, right? And we can bring the 4 outside. Okay, so now we're going to work through this one. So now my problem is my square root of 3. I have 1, I need 2, so I'm going to give myself an extra 1. Whatever we do on the bottom, we're going to do on the top. Right? My rules of radicals say, hey bud,
He's alive.
rules of radicals say that when my index is the same, which these are both square roots, remember when we're not writing them, there too, right? So now on the bottom, what happens to this 2? Does he disappear? No, he needs to come along for the ride, right? Square root of 3 times the square root of 3 gives me, I need 2, I have 2,
3.
just have my 3. On the top, what is our radical rule? My index is the same, so
15.
I just multiply what's underneath. So now I get square root of 15 over 6. Did we get the same answer?
Yeah.
Yes. So sometimes it's a few less steps
Sometimes.
if we go ahead and reduce it, okay? I'm gonna have you guys come work. Oh, sorry.
It's okay.
What do you need me to finish? What do you need me to write up? You already done with this one?
Yes, ma'am. I can see it. It's okay.
Can you still see it up there?
Yes,
You can do it.
Okay.
Let's see. I.
You can't see it?
So let's take our same concept. And
you
do
get
this.
some Skittles with it.
Stop.
I already gave you Skittles. Okay. So same concept. Here. This tells me how many do I need?
Yeah.
What is my index?
3.
A third root.
Third root.
Okay. So the problem is, okay, Tadrian, what we're doing is we have roots in the bottom. So whenever we end up with an answer that leaves a radical in the bottom, that's not fully simplified. So we're learning how to get a radical out of the denominator. Okay? And you did great on your paper that had this on it. So just let me know if you get confused, okay? Okay. So I need 3, but I only have how many? 1. So my multiplication rule says I have to have the same index. So I'm already going to go ahead and write a cube root sign, correct? I have 1, so how many do I need?
2.
I need 2. Right? Because I need 3 and I have 1. So I want to just get rid of the whole radical. So now I need 3. I have 3, right? 3 times 3 times 3 is 3 cubed. I need 3, I have 3. That's going to look a lot nicer, correct? So what did I multiply the bottom by? Cube root
Yeah.
of 9, or 3 squared.
So that's 9 times 11.
So now we have the top is the cube root of 99. And the bottom simplifies to 3, right? I need 3, I have 3, it just goes away. So now this is simplified from here.
You can do more.
No.
Wait, what?
It's a cube root.
Oh, you can't.
Sometimes you can, because when you've multiplied this in, you have an extra that you can grab from here, right? Okay. I'm gonna put some up on the board. I want you guys to come work them. Pick one. I didn't tell you where you had to go.
The big number. I didn't know. I was like,
you weren't.
Yes, I was.
You weren't.
Oh, okay.
And you can work underneath.
Oh, the marker.
Good job, Nathan.
Oh, big one.
Nazarene, you need to work from the bottom up. You want to get rid of the bottom. Excellent.
Oh, okay.
Remember, the problem is the bottom. The bottom is your problem. So you want to get rid of the radical in the bottom.
Maybe the calculator.
Oh,
No.
I can't.
I had to do 27 times.
it's 144.
But you don't need to multiply. Don't multiply it out.
Oh wait,
It
so
cancels
don't
out.
mess with the top.
Keep it. Mess with it, but don't multiply it out. Use your factors
Oh, okay.
because you're gonna need them. You're gonna need to break it out again anyway. So. Okay. What is the rule here?
What in the world? Where's the square root sign?
It isn't.
This is correct.
Mine ended up with none.
Okay.
What?
So
It's
make
9,
your fraction line.
81. 81 goes to 9, right?
So
Yeah.
it tells me I need 2, right? So how many do I have now?
2.
So what do we have left?
What in the world?
There you go.
You can't have
Yeah.
this on the
So
bottom.
you can leave that.
Okay.
So what do you have on the top
So
now?
you take
So are my
that
indexes
out
the
and
same?
this out. So it's
No.
12 and 1.
Yes, this is square
Oh,
root, that's a
okay.
square
What
root.
is this?
So all I have underneath is now what?
This
7
times
times 14.
this is this. You should.
Oh wait. these-
So is there another way you can rewrite
okay,
14?
so I don't know supposed to.
Times it or 7 times 2?
Uh-huh.
Wait, is this this 6?
Okay. So I need 2. Do I have any sets of 2 on the inside?
Yes.
Okay, so circle those. So
Wait,
where do
what?
they go? When they're circled, they get pulled out to the front. So now you have, what's out front?
It's a fraction, right?
Oh,
Is it not a fraction?
Correct,
equals.
what's left on the inside.
I thought you were doing like
And what's on the
90 or
bottom?
something.
No, I just reduced it.
Yeah.
So
Wait,
that's
Okay, now
Is that
can you
what that was,
reduce
6?
anything that's on the outside?
after I factored
Oh,
it.
yes.
Mm-hmm.
Or something. Oh, no.
So,
This is really what?
Yeah, I got the harder one.
7
Oh, I did it
Correct?
easy.
Oh, wait, no.
Yes, no, leave 14.
Oh, so you don't
I want
factor
you to,
it
because I'm gonna
inside.
mark it there.
6
So
on the
this is
inside,
really 2
Oh.
from 7.
4 on the outside.
2.
Now can you mark out?
What?
numbers?
There's 2 4s.
So now your answer
Oh,
is
yeah,
equal
you're right.
to,
There's
what's
2
left
4s.
on the top?
Oh.
No. What
Yeah,
is
you
this
doing
one?
your color.
Oh.
So it's
What's
not
left on the
this.
bottom? Perfect. Okay?
You fell.
You know what?
Is that correct? Is this correct?
Okay. Simplify this down, Tadrian.
Wait, oh, simplify that.
Simplify that now.
How many times can the 4 go into 12?
Only time 3?
Excellent.
Did you factor
Okay,
this?
yeah.
This and this.
So
don't
these
look
are
at
big,
this
these
now.
are, yeah, so your root stays, so now you would just, if you had 4 12ths, how would you simplify that? Can you simplify 4 and divide by 12? Okay,
Divide 4?
12 divided by 4.
okay, remember what it's,
4
if I
divided by
had,
12.
if I had
Oh, yeah.
2 over 6,
No,
how would I
one's-
simplify that?
Third?
One
1/3,
three,
right?
1/3.
Because 6 is really 2 times
Okay,
3,
but-
and I'm crossing out the tops and the bottom.
Oh wait.
Yes, and you don't have to have the one. Excellent. All right,
Yay.
I would be writing these down
I wrote mine very weird.
and following on papers if you want.
I'm writing in my brain.
They might be on your test.
Are you saying problems?
You never know, I mean, it helps to take notes in class, right?
Taking a picture and send it to us.
Okay, so we started with the first one, square root of 2 over the square root of 6. the square root of 6 is the problem. So we multiply times 1, square root of 6 over the square root of 6. Right? So now in the bottom, square root of 6 times the square root of 6, I have to, all we have is the radicand from underneath, okay? So we just have 6. Any square root times itself is just the number underneath, okay? So the top, the rule says, if my indexes are the same, which they are, so I've got square root and square root, I multiply underneath, so we had square root of 12. Well, what ended up happening is 6 had another 2. So when we multiplied them, we now have the square root of 12, which is 3 times 4. Right? So he pulled the square root of 4 out as a 2. We rewrote it 3 times 2 squared, right? And that's the same as 3 times 4. I need 2, I have 2. I pull that number out. 2 square roots of 3, and the 6 stays on the bottom.
You can simplify it.
What?
This can then be simplified because all my numbers on the outside are whole numbers.
So
Right?
even.
So the 2 can go into 6 3 times. Not that one. And we get square root of 3 over 3 would be our fully simplified answer. Right? You guys got that one? Okay. This one, square root of 7 over 14.
1/2 square root.
She multiplied times the square root of 14 over the square root of 14, right? We're multiplying times 1. So on the bottom now we have is 14. On the top, you have 7 times 14. So I liked how we're working with roots. She just went ahead and wrote out her factors. So she has 7 times 14, which is 7 times 2. Now she had a set. Pulled the set out. 7 square roots of 2 is what was left on the top with 14 on the bottom. Simplified 7 over 14 to 1/2 square root of 2. What if, in the first place, we had taken this one and done square root of 7 over 14?
You just do 1/2.
Initially,
1.
yes, square root of 1/2. So this is really the same as 1 over the square root of 2. Because the square root of 1 is 1.
And we could do the one.
So then you need to multiply the bottom. So there's our thing,
Just-
square root of 2 over
2.
2. Okay, same thing. Sometimes it works to go ahead and simplify in the first place. Sometimes it doesn't. Doesn't matter. Both ways get you the same answer. Okay? So look at this one. Square root of 8 over square root of 12. He multiplied times the square root of 12 because that's the problem. So that ends up with just 12 in the bottom. The top ended up 8 times 12 square root, right? So we have the square root of 8 times 12, which this is, we get 2 times 4 times 4 times 3. So here's a set, I've got 2 4s, pulled those out, 6 was left underneath. Now we have 4/12, which simplifies to 1/3. Square root of 6 over 3. Let's look at this one the other way. Square root of 8/12. Had we combined them, what would we get?
2/3.
3/4? No.
If you divide
4
by
goes
4.
into both. 2/3.
2/3. That's what I meant to say.
Right.
And can't go. Well, you gotta do the 3 thing, or like bring the 3 over if you want to.
It's the same as 2
Right?
over square root of
2 square roots of. Why didn't we get the same answer?
We did.
Where did we miss something?
No.
Oh, we missed this 2 from over here.
Oh.
Right? No, 2 times 4. 4 times
No,
3.
look. 2 times 3 is supposed to be 6. You put 2 to the 3.
Oh. square root of 6 over 3. Same answer. Okay, so a couple different options. Let's look at this one. Square root of 3 over the square root of 27. You multiply times the square root of 27 over square root of 27, so we end up with 27 in the bottom. 27 times 3 is 81. Square root of 81 is 9. 9 over 27 is same as 1/3.
Oh, you could have done 1/9, and then the 1/9 become 1/3.
If you were to put them together, 3 over 27 is the same as 1 over 9,
Which is 1/3.
which equals square root of 1 is 1, square root of 9 is 3. Okay? A couple different ways to look at it. Got it? We're gonna add a harder one.
No.
Back when we were learning, I think I gave you guys a laminated sheet.
You did.
That has perfect squares.
Wait,
Does it say perfect squares on it? Which ones I gave us? Hold the equation. I thought I gave a couple. I might have just put it up on the website. It might be on the website. Okay, so when we are looking at polynomials, okay, x minus y times x plus y, and we use FOIL, correct?
Yeah.
First, outer, inner, last. What did my first give me?
X squared.
X squared. My outers give me
XY.
a positive xy, correct?
Yeah.
My inners give me
Negative XY.
negative xy, and my last give me minus y squared.
Yeah.
Okay? The outers and the inners
Cross out.
cross out. So when you have the exact same polynomial with different signs, the insides are always going to equal 0. Okay? So you end up,
X squared minus Y squared.
okay, so now we have squares on them. Okay? Squares we can get rid of, right? If we're dealing with roots. We want things that are squared. So we are going to take what we just learned, and we're going to use that concept that we've had to look at this equation. 3 over the square root of 2 plus the square root of 6. Okay. So, first step, can I add these together?
No.
No, because they do not have the exact same radical, correct? So how do I get rid of this?
Multiply by itself.
We are going. Can I just multiply times what? Square root of 12 or square root of 2 or anything?
No.
No.
Foil.
We are going to have to use our concept that we know of. If I have x plus y, I can make squares by
Oh, that
doing the
minus
opposite. Okay.
that.
So I'm going to do. Remember, I have to have my itself. So I need a
Minus.
2 because I have 1 square root of 2. I need 2 of them. I have 1 square root of 6. I need 2 of them. But what is my sign going to have to be? Subtraction. Okay. So we're taking what we already know and we're applying it to what we have. Okay. So do I need to multiply all this out?
No.
We can. We'll do it once. I won't do it again. Okay. So my FOIL says my first 2 are squared. Square root of 2 times the square root of 2 is
2.
2. Right? I need 2. I have 2. I just got it there. My outsides,
Negative 12.
negative 12. My insides,
Positive 12.
positive square root of 12. My last,
6.
minus. Keep your signs the same. 6.
Yeah, negative 6.
Negative, positive times a negative is a negative. Square root of 6 times square root of 6 is 6. Okay? Negative 12 and positive 12 cancel each other out. So now I have 2 minus 6 equals negative 4. Okay, so this is my new bottom. Okay,
I need to do
the
that.
top had to be the exact same, correct?
Yeah.
So now, all I do is multiply, and you can leave it, you don't have to multiply it out.
What if you could simplify?
What?
What if you could simplify?
If I can simplify here,
No, like if you put it into the square roots to simplify.
I don't wanna go backwards. We always want it in the small, we want the most amount of numbers on the outside. Out from underneath the radical. Okay,
Yeah.
you guys got that?
Yes.
So this is okay, even though the top still has a parentheses and I've got some radicals that we can't do, this is still the most simplified version. Okay? Okay, let's do another one. Okay. Square root of 3 minus the square root of 5. Okay, let's look at what it looks like this way when we do the exact same. When we FOIL this, we do our first square root of 3 times the square root of 3 is 3, right?
Yes.
Our outsides, 3 times 5 is 15, square root of 15. So our indexes are the same, so we still have a square root. We multiply the inside, 3 times 5. We do our insides. Okay, and we do our outsides. Now this one is a negative square root of 5 times a negative square root of 5. So what should my sign be?
+5.
Positive 5. Okay. Is there anything that can be combined now?
Yeah.
Square roots.
The square roots, okay, Nathan, how do I combine the square roots?
Yeah, by adding, subtracting.
Yeah, we're adding, but with a negative, right?
Yeah.
So I have a negative, this is really what? -1?
Yeah.
So how much do I have left? -1 and a -1 is
-2.
-2 square roots of 15. Okay, Nazir, what else can I combine?
And 5.
3 and 5, 3 plus 5 is? 8.
Why don't we cancel them out like we did on the last problem?
Because these had the same sign. So see, they were both minus.
I see.
Okay.
The other one.
So, when you are looking at having a polynomial in the denominator, you want it to cancel out. So it has to have a different sign. So I was going to show you, when we have the same sign, we end up with 2 of them. And now we have another radical, we have another mess to work with, okay? So when they're exactly the same, you're going to get 2 of the combinations. When they're different, you just get what's under the radicals, okay? Got it?
Yes, ma'am.
Okay. So that's simplifying. There's one, let's do the one from your, I don't know that we'll get to the other. Let's do this one. Oh, those are pretty easy. Never mind. Okay, so now what we were talking about at the beginning, when we were looking at our index and our exponent, and we were doing it where we can write it as a fraction. Okay, so remember that our exponent tells us how many we have. Our index tells me how many we need, correct? So if I have 3 square roots of 5, the cube root of 5 is really 5 to the what?
1/3.
5 to the 1/3. Okay, Tadrian, you missed this part. We were going through our roots formula of saying our index tells me how many I need, how many groups I need, right? Whether I need groups of 2 or groups of 3, and the exponent tells me how many I have in the first place. So another way to rewrite that as x to the n in this way, I've got n over a. Okay, so how many I have divided by how many I need. So when we translate into that numbers, if I've got a cube root of 5, it'd be the same as 5 to the 1/3, because 5 inside is really a 1. There, so we're just gonna rewrite it as fractions, okay? And if I have the 4th root of 3 cubed, it's really
3/4.
3/4. Excellent.
Is it 3 times 3/4? Is that what
No,
you're saying?
it's 3 with an exponent of 3/4.
Oh,
This is an exponent. Remember, this is an exponent,
I was confused why you're writing it so high.
because I'm writing it as an exponent. Right? It's an exponent. Okay? So if we have the square root of 7 times the cube root of 7, my basic rules of roots says if I have a multiplication, my indexes have to be the same. Are they the same? No. So if I have them, can I just do something like this? Just multiply what's underneath?
No.
No, because my indexes are the same. This one needs groups of 2, that one needs groups of 3. That's why we can't combine them. They're not asking for the same amount of groups. So I'm going to rewrite it as a fraction. So this is really 7 to the 1/2 times 7 to the 1/3. Okay. Now back to my exponent rules. All I need is the same base. Correct? So now my base is the same. My exponent rule says I add these together. 1/2 plus 1/3 is 7 to the 5/6. Right? Okay, so let's look at that is pretty much all of those. Let's see.
We're done.
We can do this. We can take those same exponent rules that we had and we can divide them also. So if I have the cube root of 4 squared over the cube root, no, 5th root of 4, can I divide these?
No.
Can I combine them into one big one?
Sure.
No.
No, because so can I write it like
Oh, no. That you
this
can't.
or something? No, because this I need groups of 3. This one I need groups of 5. Okay, so written like this, I can't do anything with it. What if we change it to fractional exponents? How would I rewrite the top as a fractional exponent? Nazarene, how would I rewrite this one?
3 over 2.
What I have over what I need. How many do I have?
2. Oh, 2. Well, okay.
2 over 3. Okay, and what about the bottom one? Tadrian, how would I write this?
Maybe
1/5. Excellent. Okay, so now that I have it rewritten, what did my exponent rule say if I'm dividing?
They have to.
What is that exponent when you got that worksheet? What is the rule for exponents?
Subtract.
Yep, so if I have x to the a over x to the b,
A minus B.
a minus b is x to the a minus b, top minus the bottom. So now I have 2/3 minus 1/5.
Which is
What do we have to do?
making the same.
Change them into the common denominator. So 2/3 is 10 over 15.
Yes, and this would be 3 over 5.
3
sorry.
over 15.
And
So 10 minus 3 is 7 over 15. So how do I rewrite this back?
15 would be the index,
15 is your
and
index.
17 would be the exponent. Or 7, not
4
17.
to the 7th.
Wow.
Okay?
So you wouldn't leave it as.
We just leave it like that.
So you wouldn't leave it as 4 to the.
Is it
exponent?
wrong if you
It's
leave it like that?
4 to 7/15, that's fine.
Okay.
If it says leave it in a fractional exponent, you can leave it like this.
Okay.
Okay, I have 4 more for you guys to come do.